again. Today we are going to look at section 3.5, transformations of exponential functions. And this really isn't anything new. It just follows along from our transformations, which we did last unit. The only difference now is we're dealing with a different base function, which is an exponential function. So for the first part, I'm asking you guys to graph the following using Desmos and fill in the table. So I want you to go through and do this on Desmos here. Okay, and then I will fill in this part here for you though. Okay, so but I want you to verify it. So the horizontal asymptote here is going to be y equals 0. This one is going to be y equals -3. Y is equal to 4. Y equals 0. Y equals 0. Y equals 0. Y equals 0. And y equals 0. Okay, so notice one transformation for 2 to the x is none. That would be our base function. So we have 2 to the x in all these, so there is none here. This one right here, the -3 is shifting it down 3, which is why the asymptote is now at -3. This one here is down 3. This one here is up 4. Okay, we're replacing x with -x. That's a reflection, reflect y-axis. Right here, the negative is out front of the function, so that's like, remember we saw this, y equals -fx, like that, as opposed to this one, which is f at -x, right? And this is a reflect x-axis. Again, verify these with Desmos. This one right here is going to go right 4. This one here is going to be a horizontal compression by a factor of 1/2. And this is going to be a vertical stretch by a factor of 5. All right, see, it's nothing different. The only difference is we have a different base function. Okay, so now for a base function, we need key points, right? So the easiest way to get your key points is just pick some x values. So I like to always choose, usually for exponential, -1, 0, and 1 for my x, and then just plug them into the given equation. So this one here is going to be 3 to the -1, which is 1/3, 3 to the 0, which is 1, 3 to the 1 is 3. So if I plot those points, see, you get the nature of the function. There it is. Okay, so for a lot of these functions here, right, this right here, that's the key information of the exponential function. So if I gave you like just a regular exponential function, like suppose I said, okay, well, let's graph this one right here. Let's say it's like 3 to the x minus 5 plus 2. Right? Which x values would you plug in? If you plugged in -1, 0, 1, you're going to end up getting small little dots and you won't know what the graph's going to look like. That's why it's better to always use points like this and then just transform them. So move them like right 5 up 2. And that way you'll see the important part of the graph. All right. So for these ones right here, I say to sketch the following by mapping the key points above. Okay, so I'll get rid of that. I'm not going to do all of them. I'll just say, so right here we have a reflection in the y-axis down 2. So what's going to happen is the x values are going to become -x and the y are going to be y minus 2. Okay, so the new key points, so if I change each x value, so now it's going to be -x, so it's going to be 1. Okay, and then we have 1/3 minus 2. So common denominator, so it'd be 6/3, which will be -5/3. Okay, next one will stay at 0. And then we have 1 minus 2, which is -1. And next one will become -1, comma 3 minus 2, which is 1. Okay, so we'll do a different color here. So we're going to have 1, negative 5 over 3. Okay, it's almost 2, so put right there. 0, negative 1, and negative 1 and 1. Okay, and what do we get? Okay, you also should put in your asymptotes. It's down 2, so we'd have like your asymptote at negative 2. So put your asymptote in and then draw it. So it's a reflection on the y-axis down 2, and that looks right. Okay, now these ones right here, I'm going to have you guys sketch these, right, and then just plug it into Desmos to make sure it's correct. Right, so this one right here, because that's a 0.5, remember it's always 1 over 0.5, so it's going to be 2x and then negative y. And this one's going to be, it's going to go left 4, so each point you're going to subtract 4, and you're going to add 3. Okay, so get your new points and plot those. Okay, so now we're starting off with a different base function. It's now 5 to the x, and I'm saying write a new function that reflects each of these. So a reflection on the x-axis. So we're going to go negative f or 5 to the x. So again, plug this one into Desmos, y equals 5 to the x, and then plug each of these in just so you see it. Okay, shift left 4, left 4. So we're going to replace x with x plus 4. Okay, reflection in the y and a horizontal stretch by 3 that affects the x's. Y is equal to 5 and it's going to be negative 1/3 x. Okay, and the last one is a vertical stretch by 4. So that means that the 4 comes out front times 5 to the x and then a plus 1. All right. Okay, and the last example here, we're going to list the transformations to the function y equals 3 to the x that result in here. So we'll start off with the negative, so that is a reflection in or on x-axis. We have a vertical stretch by a factor of 4, and we're going up 1. Okay, those are the y's. I'll write the x over here. So we're going to have a horizontal compression by a factor of 1/2, and we are moving right 4. And that is it for today.